Let's compute the measures of goodness of fit for the model based on empty cars dataset. I'm copying empty cars to df object and building the linear regression model. LM is the function that we used previously to build a linear regression, computing the summary and storing the summary in model summary object. Now, three of the four measures of goodness of fit is seen in this output itself. We have the R square, adjusted R square and F statistic. Only AIC is missing. To compute AIC, you can use the AIC function that will give you the AIC value. Likewise, to compute BIC, you have BIC function. Let me demonstrate why adjusted R square is better than R square when you are comparing different models. I am creating a new model. First, set the seed to 100 so that this model can be reproducible. I'm going to build a new model with an additional term. This is a random term that I am adding to the formula. Obviously, this term is not as significant. If you see, there is no significance to this particular term. But if you look at the R square value, previously the R square value of the previous model is 82.68. Now this R square has improved from what we had previously, 82.83. But if you look at adjusted R square, this has come down. Previously the adjusted R square was 0.8148, that is 81.48%. Now this has deteriorated. So clearly adjusted R square is a better metric over R square. If you want to extract these values directly as a particular variable that you want to store, you can access these values from model summary. Note that this is not accessible from the model object. You can only get these values from model summary. To get R square, use model summary $r dot square. Likewise, you have for adjusted R square, F statistic, AIC and BIC of the respective model. That's quite straightforward. There's a mini challenge associated with this topic. The challenge for you is we have three different models. Model 1, Model 2, Model 3. The equation of this model is shown here. Alternately, you can just run this command source followed by bit.ly slash 2 capital Y H capital V capital M CW. In this URL, you have this code if you do not want to type this. Which amongst these following models is better in terms of R square, adjusted R square, AIC and BIC? If you have access to RStudio, pause your screen, try it out and come back and check for the answers. Here are the answers for these exercises. I'm computing the summaries. And these are the values. The second model has the highest R square as well as the highest adjusted R square. Also, the AIC and BIC of the second model is better than the first and the third model. So clearly, this model wins over the other two.